Bu arada bize katılımını sağlayamayıp çalışmanın başarılı geçmesi ve çalıştay boyunca katkılarının daha sonra olacağını belirten İstanbul Büyükşehir Belediye Başkanı Kadir Topbaş, Profesör Doktor Mehmet Görmez Diyanet İşleri Başkanı ve TÜBİTAK Başkanı Profesör Doktor Arif Ergin de program yoğunluğu nedeniyle katılamayıp Çalıştay'a başarılar dilediklerini ilettiler. Çalıştayımız konuşmacılarımızla devam ediyor olacak. Ensuring Success in Big Data sunumu ile devam ediyor. Konuşmasını yapmak üzere Sayın Harald Müller'i kürsüye davet ediyorum. Evet.
Okay. Thanks a lot. It's a great pleasure to be here. It's an honor to be here. To give you a little bit of a background on Datamir and my person. So don't worry, I'm not going to give you a marketing pitch here. However, Datamir and the predecessors of the company, we've been doing big data projects long before anybody was talking about big data. So the company, or the predecessors of Datamir as a company as it is right now, already started the first big data projects in the public sector in the very late 90s. Actually, the first project that we ever did, as I said, long before anybody was talking about big data, was a contextual text analytics solution for the Central German Library. And ever since, we continued working in that space, and I think a major event that then led to the foundation of Datamir was our contribution to the open source project Hadoop. Who's heard about Hadoop in this room before? Okay, excellent, good. So like 1/3 approximately. So the founding team of Datamir actually co-invented Hadoop 10 years ago. And I'll talk a little bit more about what Hadoop actually is. After that, the founders continued to carry on working on custom big data projects in the public sector, with lots of governance, with security agencies, also in the telecommunication space as in the banking sector. And 2009 ultimately decided to build or to productize what they have been working on so far and establish Datamir as a software vendor selling big data analytics solutions. So much to Datamir as a background, and what I'd really like to do within the next 30 minutes is to give you well, an impression of what we're doing and share the best practices with you that we have experienced over this long big data journey, like the do's and the don'ts. But let's start out by talking a little bit more about what is big data. So a couple of quick facts here is 90% of all the data that is currently being stored was created over the last 2 years. And I think one of the previous speakers already mentioned it. There's an enormous amount of data currently stored globally, and it is estimated that this data that is currently being stored and very often not processed doubles every 2 years. That's how we get in those zettabytes range that you were talking about. Now, what's also very interesting and what's challenging in terms of a technology perspective is that about 80% of the data that is currently being stored is either semi-structured or completely unstructured. Now, semi-structured are log files coming from the Internet of Things devices that we wear, the smartphones that we carry around with, from trains, from you name it, but also completely unstructured sources like text files or communication recorded via a call center. And I think what's also very important for us to know in order to make decisions for the technology stack with which we want to attack big data is that the amount of semi-structured and unstructured data grows 15 times faster than the amount of structured data, which already gives us a hint that maybe traditional technologies such as relational databases that are doing very well with structured data might not be the right answer for the future for really dealing with big data. And that's another tidbit I wanted to share with you. I was surprised by that myself. 20 households nowadays They create as much data, as much internet traffic as the entire internet in 2008. So, okay. So this is a study from 1997. This is how management was back then making decisions. About 88% was based on the gut feeling. I must admit I'm still doing that probably most of the time. And only 12% were made on hard facts. Now, in the emergence and in the hype of big data, what you would expect nowadays is that that number, I mean, with the emergence of all the predictive analytical tool sets, R, SAS, you know it, you would expect that this is much, much higher. But actually, there's a study out there that outlines that the amount of data that is being used to make management decisions has actually decreased. Now, the reason for that being is obviously the amount of data has grown, and therefore the amount of data that we can use in order to make intelligent decisions has actually decreased. We also made a survey together with some of the other big data vendors, and we compiled that data. And we wanted to understand what are really the drivers of big data projects nowadays. So 6% answered that it's about identifying new services and products. 9% said it's more reliable decision makings. 11% it's really improved operational efficiencies, making organizations, making units work more efficient with less cost. 31 said it's really identifying new market opportunities, understanding how their customers interact, and then optimizing the product offering. But the astonishing fact was that 51% of the data initiatives, the big data initiatives that are being currently driven is driven by organizations that don't really know anything about the use case that they're working on. And I can sign up for that. Within all those years that I've been working in big data projects, I've been working to huge organizations, governmental organizations who've deployed a data lake, 1.5 petabyte of data lake, but then of a 1.5 petabyte data lake. But then when it really boils down to the conversation, so what are the applications sitting on it? What's the benefit you're deriving it? What type of analytics you're doing with that? You get the answer 0. Yeah? This is true for the public sector, but it's also true for the private organizations. Same story for a German car manufacturer that I'm working very closely. They spun up a 2 petabyte cluster in India. Nobody's using it. Yeah? So that's, people are very often doing it, establishing like a Hadoop cluster, because everybody else is doing it, but nobody really knows what it's good for. That's another interesting observation. So one thing, now coming more down to the actual technology and the challenges related to it, one thing that we have seen through all those years is data complexity is increasing. I've mentioned it. We've got all those different data sources. To get insight into that, extremely difficult. At the same time, the time to decision has decreased massively. Both in the public sector as making decisions for crime prevention. Yeah? The time for that is, I mean, it's really, with all the speed in that sector has dramatically decreased over the last 20, 30 years. To identify potential threats, it's really, it's a matter of hours, maybe days, but not months of investigative work to make the right decisions. So, for example, we helped the Boston police to identify the actual bomber during the marathon there with our big data technologies. I think it's even more crazy in the private sector where, companies are launching products and within days they need to steer their marketing efforts in the right direction, otherwise their campaigns are going to fail. A good example is always like you had 10 years to launch the Microsoft ovens, but to launch a new mobile phone, you got about 8 weeks in order to, make sure it works or it doesn't work. At the same time, what we're also observing is, hardware costs are being reduced dramatically. Ever heard about Moore's Law? Moore's Law says that every 2 years, hardware capacity, speed doubles, but the price is reduced by 50%. But yet, at the same time, the cost of people is dramatically increasing. not only the cost, but they're also rare. You know, you've got all those fancy technologies out there, but to get the right skill sets is very, very difficult. And that ultimately, you know, leads, you know, to the whole big data problem, what it's all about. So we, as a matter of fact, we as Datamir, we don't really like to talk about big data, because I think big data was created by big companies to earn big money, and it's a big buzzword. I'd rather talk about data complexity, and there are three factors influencing data complexity. Of course, number one, it's the sheer volume of data. Yeah? But if it's only structured data, and if you want to help Larry Ellison from Oracle to buy the next chip, just continue buying Oracle licenses. Yeah? But as soon as you got the second V coming in, the variety, the heterogeneity of data sources, when you're dealing with structured and semi-structured data, and you want to combine those to get insights into the data, then the old approach is not going to work. Traditional enterprise data warehouses, relational database technology is just not going to work as soon as those factors come in. And then the third V of data complexity is really the velocity in which you need to incorporate new data sources. Yeah? So it's not a static world anymore. You know, you got new data sources, new social media sites coming up that you might want to analyze in order to understand better what is the population talking about. You know, what is your customers talking about? What are they tweeting? So just a new website came up, which is Snapchat. They're sharing lots of information there. You got to make sure this information is also incorporated in your data lake. So those are the three V's that really make up big data. So much to the overall big data picture. Now let's talk a little bit about this thing called Hadoop that I already mentioned. And I'm going to start out by talking about that by actually looking on a use case. I mean, the public sector, governance, cities, the police, security agencies, and the same is true for the public sector, for marketing agencies who want to sell something. They're interacting with their customers, and I'm using that as a very broad expression for the people out there. They're interacting with your organization in many, many different ways. I already mentioned it. There's the social websites. Then there's something like I call it CRM system. There's information stored statically about the population in many, many different databases. You're driving campaigns, you're driving advertisement campaigns via tools such as Marketo. You want to measure the impact of those campaigns with Google AdWords, Google Analytics. I think one of the previous speakers already mentioned that they're using tools from Google in order to get information about that. There's the call center data. I mean, people are still calling agencies, right? And they're complaining about stuff. They're raising concerns about stuff. So all of that, it's a massive amount of communication channels that you need to take care of. And in order to truly understand what is the issue, what are people requesting, what is worrying them, to understand really how they interact with your organizations, the only way to do that is to combine all of those different communication channels. And you can only do that by combining them in one central data lake. So that's a very popular expression that, by the way, also is addressed in our name. Data, obviously, that's the data piece. Meer, we have German roots, is ocean. So the only way to address that is really by putting all of those different silos, information silos, in one central data lake. I mean, obviously, all of those tools like Google AdWords, Marketo, Facebook, etc., Twitter, they come with their own analytical solution, but they only give you, a siloed view. And the only way to overcome that challenge and really understand what's the world out there like, what are people talking about, how are they interacting with you, how are they navigating your websites, what documents, what forms are they downloading and uploading, If you really want to understand that, the only way is to load all of that information in its raw format into a central data lake. And that data lake, as technology stands before, is an open source project that we contributed in massively 10 years ago called Hadoop. That's, as far as I know, that's the only database engine that's currently on the market. And keep in mind, this is open source. Yeah? that can handle all of those different communication channels and store the information there. So what actually is Hadoop? Well, I'm sure all of you are aware with VMware. So VMware was the approach. You had one server, which usually was underutilized. So you put lots of physical machines, you spun up lots of virtual machines sitting on one physical machine. Now think of Hadoop as exactly the other thing around it. Hadoop was invented, or let's put it this way, Hadoop was pushed by Google 10 years ago. Hadoop was what was Google using in their data centers 10 years ago, and they made that information public 10 years ago, and that's what started the open source project sponsored by Apache. Yeah? And Hadoop is, well, if you want to think of it as a very high level, it's a new data analytics paradigm, yeah? A completely new approach to data analytics. It splits up the data that needs to be analyzed in small chunks and stores it redundantly over what is called a cluster. And a cluster is basically a group of physical machines. Can be as many, that's one of the beauties of it, as you want. Hadoop has, especially with Hadoop 2.0 that came out last year, has no physical limitations. You can have clusters as big as tens of thousands, hundreds of thousands of machines. The data is stored over that cluster redundantly, and the analytics are executed in parallel over that cluster. And as I said, it scales in a linear manner. You want to have double of the computing power, you just double your machines, and you're going to have double the performance. It's also, as I said, data is stored redundantly, so there's built-in redundancy. So if one of the server goes down, and if you think about a 10,000 node cluster, they will go down. You just, during production, you rip out the machine and you replace it by a new machine, and the system will take care completely by themselves. So that's really what is currently, that's what's state of the art in data analytics. As I said, a completely new approach to data analytics. The approach that you probably all know of data analytics in the enterprise data warehouse space is that you start out by building a database schema. That's pretty tricky. I've never seen the perfect database schema yet. You take your raw data, you slice and dice it to make sure it fits into the database schemas. That process is called ETL. It stands for extract, transform, and load data into a predefined database schema. And then you put a BI tool, a business intelligence visualization tool on top of that. That is again depending on the database schema, so that that data can be consumed by the business users, by the actual people, by the managers who make the decision. That's a very lengthy process. According to the Data Warehouse Institute, this process takes about 18 months to set up initially. To ingest new data sources, that's going to be about 3 to 6 months. Now, looking at the previous slide where we talked about time to decision, heterogeneity of data sources, velocity of data sources, that's not going to be good enough anymore to handle the challenges related to time to insight in the modern world. And that's why the Hadoop approach is totally different. You take the raw data from the data sources, you dump it into Hadoop without any transformation whatsoever, and you create views on the data as you consume it. So the old world approach, the previous approach in the enterprise data warehouse world, was a schema on write, which means you think about the database schema before you store the data, versus the new approach, and that's where the paradigm change comes in. It's a schema on read approach. You create the schemas, you create the views on the data as you consume the data. The benefit of that is, as I said already, traditional BI takes about 18 months to set up with. Now, don't make the big mistake, and that's coming to the best practices that I wanted to share with you based on our work, of taking, the Hadoop approach or taking Hadoop technology and then implement the old approach on top of that. Lots of organizations are doing that. They create a schema on Hadoop. That doesn't make sense. Hadoop was not meant for that. Plus, if you go for that approach, you're going to have the same issue again. It's going to take you very, very long because you need to come up with a schema. You also need to have lots of people, you know, who understand all this new technology. It's maybe going to take you even longer from that. No, my strong suggestion to anybody, you know, moving into a Hadoop project is really, you know, follow the Hadoop approach by loading raw data and creating a schema as you consume it on the raw data, which will allow you to iterate and create use cases within weeks instead of months or years time frame. That would be my recommendation. In terms of how the big data ecosystem looks like, as I already told you, in terms of infrastructure, the underlying hardware, multiple servers, potentially thousands, 10,000s of servers. On top of that, you put the Hadoop distribution of your choice. In the previous conversation, we already seen the two logos there, Hortonworks, Cloudera. There are a couple of other vendors out there. As I said, Hadoop per se is open source, but just like with Linux, which has been around for some time, you can buy support for Hadoop. And MapR, Cloudera, Hortonworks, but also the traditional players like IBM, EMC, they also have supported solutions, which is basically just a support package around that. And in terms of the analytical stack, I do have to make some commercials for myself, is where, you know, a company like Datamir comes in, which puts on an abstraction layer on top of Hadoop. It hides all the complexity of Hadoop. You don't need to understand anything of the underlying technology and helps you to implement those use cases on a very, very quick turnaround. As a matter of fact, what we offer is basically a spreadsheet-like user interface to a Hadoop that allows you to create views on Hadoop on demand. So if you ever worked with Excel, you can basically work with our solution. But there are other vendors out there. I said I don't want this to be a marketing event for Datamir. But that's how the stack from an architectural perspective looks like. You got the hardware, you got the Hadoop distribution, you got an analytical solution sitting on top of that. So let's talk about how to pick the right strategy. We've seen, as I told you, almost 20 years in the business. We have seen so many projects fail miserably, and we've seen also a couple of them working out very, very well. So how do you pick the right strategy? Well, first of all, the most important thing is identify use cases. I already told you previously, 51% of the big data projects, the project owners don't even know why they're doing that. First step, even when we engage with customers, is identify the use cases. Make sure you have the right use case in place to start with. Don't just spin up a big cluster like this car manufacturer or like those governments in, that was in the Middle East. For nothing, make sure you've got something really beneficial that you want to achieve on that and get the people on board with that. It's got to be, don't try to boil the ocean, you know. There are lots of use cases that say, you know, oh man, we can like half the cost of our public administration, or we're going to reduce healthcare overhead by 80%. Don't boil the ocean. Start with something small that gives you fast results. And make sure that the problem that you are addressing really is a problem. Because very often when we talk to people, you know, people do have a problem, but they say, yeah, you know, it also works with the way we're doing it and we have tweaks and ways around it. So make sure you have something super, super compelling in place. That's like the most important issue when starting a big data project. And then get the right teams on board. Obviously, you know, somebody's got to pay the bill, so know the economic buyer. But most important here is the middle one. Yeah, this one here. Get the business units involved. Get the managers involved. Don't make it just a technical initiative. Yeah? Really get the end users into the project. Make them part of deploying it. You know, it should be already part of the finding the use case exercise. Again, if it's only an IT initiative, and even if it's only an initiative driven by the traditional enterprise data warehouse and BI teams, those projects are going to fail. Then, that's another tricky part, identify the data sources. One of the challenges that we see in our work on a day-to-day basis is that we talk to customers, you know, we have all the right conversation, we have the right teams in place, and they came up with those wonderful use cases, you know, about, as I said, you know, reducing health costs, optimizing energy consumption, smart city projects, brilliant ideas. And then when we go down to the next step and say, hey guys, so, you know, what's there? What can we actually use? What are the data sources? very often we find out there's a whole lot of information missing, and even information that is available is not accurate. Just, worked with a Asian government agency who was planning to do a very interesting healthcare project. And ultimately, when we analyzed the data, we said, hey, your CRM data just is full of holes, data quality, big issue that you need to make sure that you've got all of that. Then data security, very important in the public sector. Make sure that the government, the use cases that you have in mind, don't trip over the data security issues, because what we've also seen in the past is we've implemented the whole stuff, and then at the very last moment, a lawyer came on board and dropped, boom, 1,000 pages of of legislations and law on top of our desk and said, guys, you can't do that. So make sure you got those guys on board right from the beginning. Otherwise, this is not going to fly. And then get started. Obviously, buy hardware, buy software. But again, don't make a science project out of that. We have seen projects that have been delayed by half a year, because people got so hooked up on finding the perfect hardware with the lowest price. They got so hooked up on identifying what is the right Hadoop distribution. Is it Hortonworks that performs a couple of milliseconds faster than Cloudera or MapR? Just pick any. They're pretty much, at the end of the day, they're all good, And don't get involved with that, because it's really all about time to insight. That's what it's all about. It's not about executing the optimal query speed. You can tweak that later on once you have that in production. And then again, I know I'm repeating myself, get the SMEs on board, the subject matter experts, the business users, those guys that really can make business use out of the data. And let them think out of the box, let them be creative. You might, get tremendous results out of those data discovery initiatives. So, make them part of your team, let them dream up those things. We've always seen once you've got those, really the data experts on board, they can make a really big difference. And this is a study that proves what I've just said. Companies that basically democratize their big data projects to the business users are 50% more successful to big data initiatives that basically, keep the whole data lake in their own silos. By the way, another thing that we see very often, where the data scientists or the IT department is owning the data lake, the Hadoop cluster, and is not giving access to anybody outside. If that's the case, there's a high chance that those projects are also going to fail. So, and then once you have that in place, iterate. Don't just keep it static. Keep it open to the rest of the world. Iterate them. Find new use cases. Start small. That's the key takeaway. Start small. Find a compelling use case. Get the business users in place, the subject matter experts, and then once that is done, expand. That's what we're seeing most of the time. So, to wrap up, a couple of use cases that we're currently working on. This is a super interesting project about understanding, it's a healthcare project. We are working with a Middle Eastern governmental organizations who are basically combining their existing database from their health insurance systems with demographic data, enriching it with weblogs. How are people interacting from the outside with weblogs and the call center to get really new insights into, what's the expected spend on healthcare over next period given time. And we're using Hadoop as a basis there and some predictive algorithms in order to get predictive insights into those cases. Another very prominent use case is both in governmental organizations, but as you can imagine also in the financial services industry, is preventing fraud. So as I told you, beside public sector, we're working a lot with banks and insurances and credit card organizations, and we have saved, I can name them. We're working with Visa and American Express. They're public references, and we're saving them billions of dollars in fraud, because what they're doing is they're looking at the transactions that they have in place. They're combining them with the amount of the transactions Because nowadays credit card fraud is not somebody steals your credit card, it's somebody doing microtransactions. And demographic data, and by such they're identifying fraud patterns that they're then feeding in their real-time analytical engines that are preventing those frauds. And they're readjusting those fraud patterns on a weekly basis to make sure that they always catch the latest and greatest on credit card fraud. Smart cities, oh my God. I'm 100% sure this is going to be a killer in 2016. We have dozens of conversations around smart cities. That by itself, I think, is a separate workshop that probably can occupy us for 2 days or more. Yeah? It's about so much. It's about crime, preventive crime detection. So we've done projects like with the Detroit police, with the Boston police, but also we are doing a super interesting project right now with Europol, which is actually chasing up vendors of child pornography, and that's just one aspect. Then there's the whole thing about smart grid computing, energy consumptions, making predictions about energy consumptions, optimizing traffic, collecting sensor data from the trains. We're just doing a project in the Netherlands with Dutch Railways, where they're those guys, surprisingly, in the Netherlands, can you imagine, they're having big issues with delayed trains and the cost associated with that. So we're analyzing train log data to optimize the availability of trains, doing preventive maintenance. That's a massive area that's going to grow really big in the years to come. Product enhancement, that's a little bit out of your range here. It's a different vertical, something we're doing with the gaming industry, where we're optimizing gaming websites, Facebook games, A/B testing, what increases the stickiness of computer games. Yeah? Stickiness means what keeps players playing longer with a game and buying more. Is it this version of the game or this version? So we are doing a lot in that as well. We are working massively with telcos. I think one of your previous discussions mentioned the telecommunication industries who are opening up the wealth of information they're storing about their customers to public organizations, to governance. And we're doing a lot in intelligent network capacity planning by combining network data with customer data, combining 2 different data silos to get completely new insights and enable telecommunication service providers to make more intelligent decisions as to where should I invest in my network, instead of just, by random, okay, I've got a performance issue there, I'm going to put another base station here, right? So we can help optimize that as well. We've done lots of projects in the oil and gas industry. As you can imagine, Middle East, that is a government thing. So we've done a lot in optimizing, wells by identifying what's the perfect well configuration and really, increase oil productivity massively. So this is just, I could ramble on about use cases we have deployed over the last years, and I'm happy to stick around. This is the last slide. I'm already getting the evil look here. I hope I didn't overrun too long. So I'm still going to be around, guys. Please, ping me any questions that you have. Again, thanks for having me here. I'm really honored and proud to be able to speak to all of you. By the way, we are expanding into Turkey and the Middle East. We have just opened an office here in Istanbul. Turkey, Istanbul is going to be the hub for Datamir to expand in the region and in the Middle East. And my colleague Gökhan is going to be running that region for me. So we're hiring technical teams here, and I'd be really excited to be part of that laboratory, for example. We'll be super happy to provide you with the software and make use of that. Thank you very much.
Thank you very much, Mr. Mueller.